In Metro Manila, only 11% of the total population is connected to a sewage system, and 85% are served by over 2 million poorly maintained septic tanks. Many others do not have septic tanks at all. All their wastes end up in water bodies, polluting rivers, creeks, lakes, and even the oceans. This is the reality across the country. But what if we can recover the sewage and turn it into fertilizer? This is what Project NexCities is all about.
NexCities is actually the first project of its kind that focuses on fertilizer production from wastewater in the Philippines. This contributes to UN SDG number 6, that is, clean water and sanitation for all.
We try to help achieve food security through the potential development of a new business model that is based on fertilizer recovery from septic wastewater. We envision a future where small farmers can be involved in the new wastewater recovered fertilizer industry, since they are most affected when the price of fertilizer spikes.
The role of the farmers in the project is basically to confirm how effective the struvite that we have produced in terms of use on the crops. So later, when there is enough that we have produced, we could distribute it to them and test it themselves in their own farms.
We employ science, technology, extensive studies and field trials, and make sure that we adhere to prescribed standards in research and project implementation. We also value partnerships, where different sectors can learn from each other.
The partners of the NexCities project include University of Surrey in the UK, my home institution, Salle University in the Philippines, the lead institution in the Philippines, and other institutions in the UK and in the Philippines. For example, University of Nottingham in the UK, De La Salle Araneta University, Salikneta Farm in the Philippines, and SCPW, Society for the Protection of Philippine Wetlands in the Philippines.
We are at this stage of the project wherein we are now testing the recovered phosphorus from this septic to produce crops like tomato and other vegetables.
There are two main challenges that the team has experienced during the project. One is the volume of struvite that we are able to recover. So from 100 liters of septage, we are only able to get around 3 kilograms. And the other challenge is its application. Since the nature or the material is powdered-like, so it's hard to apply it in the amounts that is needed by the crop.
One of the main challenges that I face is managing the project virtually. I hope that maybe in the future we could have this face-to-face meeting with the members of the team.
So by the end of our NexCities project, we hope to demonstrate for the first time in the Philippines through the implementation of the concept of circular nutrient economy, which is stemmed by wastewater nutrient recovery and recycle into agriculture. So this demonstration can show multiple benefits. For example, sustainable agriculture, sanitation for all, and protection of water resources in the Philippines.
My dream after this project is actually to change the mindset of people, looking septic differently, looking at it not as a waste but as a resource to produce fertilizer and help farmers to grow crops.
Project NexCities, addressing the water and sanitation challenges in the Philippines for a better future for all.